7.5. It's called the quadratic formula. This will be our last method for solving quadratic equations. So what are our methods for solving quadratic equations so far? What are our choices? Factoring is one choice. Completing the square, that's what we did the other day. Square root method. And of course we could use our calculator. So at this point we have 4 options. Today we're going to add a 5th, the quadratic formula. What's good about the quadratic formula? The best thing is it will always work. It will work for any quadratic equation. So it's similar to completing the square. Completing the square always works. Our other techniques sometimes worked, sometimes didn't. Quadratic formula will always work. The bad news with the quadratic formula is you've got to know it. If you don't know the formula, you can't use it. So you're simply going to have to sit down and memorize it at some point. All right, so here's how it works. The y equal ax squared plus bx plus c, where a is not the number 0. And we want to solve ax squared plus bx plus c equals 0. And we're actually going to derive the quadratic formula. We're actually going to figure out what it should be. And I think it's important for students to see this because a lot of times people think that these formulas just come magically out of the air. The quadratic formula is actually pretty simple where it comes from. Figuring it out isn't real simple, but we'll see how bad it is. All right, so what we want to do is we have a quadratic equation. It's quadratic because it has an x squared. We want to solve this equation by completing the square. The quadratic formula is really just a fancy way of completing the square. So if I want to complete the square, what has to happen? What's the very first thing I need to do? Minus c on both sides? Okay, that's fine. You really had 2 choices for your first thing, and that's one of them that's acceptable. We move the number over with right minus c. What's the next thing we need to do? Well, this number right here, a, has to be the number 1. Maybe a is the number 1, maybe a isn't the number 1. But I need to make sure I have a 1 right there. How can I make sure I have a 1 right there? Divide everything by a. So I'm going to divide by a. When I divide by a, I've got to do it everywhere. And we saw this the other day that sometimes when you've got to divide through, you've got to deal with fractions. Kind of a pain in the neck, but it'll work. So we have x squared plus b over a x equals minus c over a. Our next step was to add a special number to both sides. What's the special number we should add to both sides? We take the thing in the middle, which is b over a. We divide it by 2. And then we square it. Square it, not square root, square it. All right, so here's where the hard part comes. The hard part with these problems is always messing with these fractions. What I'm going to do is I'm going to think of 2 as being 2 over 1. So how do I take a fraction and divide by another fraction? Flip and multiply. Multiply by the reciprocal. So this becomes b over a times 1 over 2. And then that whole thing is going to be squared. So I'm going to write that as b over 2a, whole thing squared. I just multiplied tops, multiplied bottoms. That's b squared over 4a squared. I square the top. b times b is b squared. Square the bottom. 2a times 2a is 4a squared. So there's my special number that I need to add to both sides. Not a very nice special number this time, was it? Yeah, oh well. So I'm going to put it there. b squared over 4a squared. b squared over 4a squared. Now, if I've done things correctly, the left-hand side should factor in a very special way. If I've done it correctly, the left-hand side should factor like that. x plus b over 2a. And how do you know it's x plus b over 2a? Because it's the step before. The number that goes inside these parentheses is always the number that was inside this parenthesis right before we did the squaring. All right, now on the right-hand side, I've got to do some work. The right-hand side is kind of a mess. I have two fractions, and I'm adding, and I'd like to put those together. In order to add two fractions, what do I need to have? A common denominator. So I think the common denominator, this one just has an a, that one has a 4a squared. I think the common denominator is 4a squared. So this fraction right here, to get the common denominator, I need to multiply top and bottom by 4a. So I'm going to have minus 4ac over 4a squared plus b squared over 4a squared. So all I did there is I got a common denominator so I could add my fractions. All right, so I'm going to rewrite this. I'm just going to write x plus b over 2a squared. I didn't do anything there. And on this side, I'm going to write this as b squared minus 4ac all over 4a squared. So I combined my fractions, and I chose, just because this is the way it's usually written, I chose to put the b squared first. Because when you see this formula, that's the way it's usually written. B squared usually comes first, and then minus 4ac comes second. So I switched the order on them just because that's a standard way to write it. Okay, we're almost done. What do we do now? How do I get rid of this square right here? Square root both sides. So I'm going to have x plus b over 2a equals plus and minus the square root of b squared minus 4ac all over 4a squared. What's that? The formula is starting to show up there, isn't it now? All right, so I'm going to do a couple more steps and we'll have what's known as the quadratic formula. X equals, I'm going to move this piece over, so I'm going to have negative b over 2a plus and minus the square root of, I'm not going to do anything with the top, I'm just going to leave that as b squared minus 4ac. But down on bottom I can do some nice things. What's the square root of 4? 2. And what's the square root of a squared? A. Squares and square roots are inverses. Square root of a squared is a. All right, so here's the formula. Here's the way it's normally written. X equals negative b plus or minus the square root of b squared minus 4ac, and then notice we have a common denominator, so I can put the whole thing over 2a. And it looks like there's a smudge on my paper. That's not a minus 2a right there. So I'm just going to put a plus there just to make sure. It's a plus 2a on bottom. All right, so there's the formula. The beauty of that formula is it will always work. It will always give you the right answer. What's the downside of it? You've got to go home and memorize it. The only way you can use it is if you know it. If you don't know that formula, you can't use it. You have to go home, sit down, and memorize it somehow. Okay, well here's how we're going to use it. Solve. 3x squared minus 5x minus 8 equals 0. Does that problem factor? Maybe. But the reality is factoring on that one would kind of be a pain in the neck. How come factoring would kind of be a pain in the neck? Well, factoring is always kind of a pain in the neck when that first coefficient is not the number 1. So maybe it factors, maybe it doesn't. I don't know. Can I solve by completing the square? I can. Completing the square always works. But again, kind of a pain in the neck because this first number has to be the number 1. So the first thing I need to do is divide everything by 3, and right away that's going to cause a bunch of fractions. For this problem, I think the best way to solve is to use the quadratic formula. So I'm going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be, how much is negative b? Positive 5, because b is the number negative 5. So negative b is going to be negative 5. So that's going to be positive 5. Plus or minus the square root of, how much is b squared? 25. Negative 5 times negative 5 is 25. Minus 4 times a is the number 3, and c is the number negative 8. Watch your signs there. That's an easy one to forget. C is negative 8. It's got a minus sign in front of it. All divided by 6. How did I get 6? 2 times 3. A is the number 3. Now all you have to do is take your calculator and clean it up. So I grab my calculator, and I'm going to type in 25 minus 4 times 3 times negative 8. That's 121. So we end up with 5 plus or minus the square root of 121 over 6. Is the square root of 121 a nice number? Yes, square root of 121 happens to be 11. So this is 5 plus and minus 11 over 6. So when that square root thing turns out to be a nice number, we usually would do this. We would write two answers. We would write x equals, I would take 5 plus 11. What's 5 plus 11? 16. So one answer would be 16 over 6, which is 8/3. Or x is 5 minus 11, negative 6 over 6, which is negative 1. So if that square root turns out to be a nice number like 11, usually we split it up and we write our answer as two separate fractions. We don't normally leave our answer like that. Is it wrong to leave it like that? No, it's not wrong. It's just not the way we normally do it. Normally, if you have nice numbers here, split it up and give me the fractions. Questions about that? Now what that tells me, I ended up with fairly nice answers. What that tells me is that that problem would have factored back at the beginning had we tried to factor it. Anytime your answers don't have square roots in them, it would have factored. But again, I think using the quadratic formula for that problem is actually easier. All right, let's try another one. Somebody make up a number for me. Anybody got a number? Any good numbers? Eight. X squared. Minus 3x. Plus 5 equals 0. Again, maybe that problem factors. I don't know. Personally, I wouldn't even try. Factoring when this first number is the number 8 is kind of a pain in the neck. I could complete the square. Again, a pain in the neck because I've got to divide everything by 8 and I'm going to have fractions right from the beginning. I think the best way is to use the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. How much is negative b this time? 3, because b is the number negative 3. So a negative 3 is a 3. Plus or minus the square root of b squared is 9 minus 4 times 8 times 5. All over 16. So that's 3. Plus or minus, I grab my calculator. 9 minus 4 times 8 times 5 is negative 151. So I have square root of negative 151 all over 16. Is the square root of negative 151 a nice number? No, so what do? The only thing I do is I get rid of the negative underneath the square root and I write it using an I. So my final answer for this one would be 3 plus or minus I square roots of 151 over 16.
Do you always put the I out in front, or do you put it behind 150?
Depends on who you ask. The problem with putting it behind is it kind of looks like that.
Yeah.
And somebody might say, is that I underneath the square root or is that I not underneath the square root?
Okay. I just know.
So traditionally we put it in front. The other option, this is what my high school teacher used to make us do, is to put a little bar like that to clearly indicate that that's where the square root ends and the I is outside of it. If we wrote it that way without the little bar, my high school teacher would mark it wrong. He would say it was unclear. So traditionally we put the I in front and then you don't have to worry about it. Then there's no doubt at all.
Okay.
Other questions? Okay, how come this one came out with complex answers and the first one didn't? Well, the first one did factor, that's true. So if you can factor, you're never going to get complex answers. Let me rephrase my question. What part of the formula is going to determine if your answers turn out to be real numbers or if your answers turn out to be complex numbers? The b squared minus 4ac. So when do you get complex answers? When this b squared minus 4ac turns out to be negative. When that turns out to be negative, you're always going to get complex answers. When are you going to get real answers? When it's positive, when b squared minus 4ac is positive. What if b squared minus 4ac is the number 0? That can happen. What if b squared minus 4ac is the number 0? Let me give you an example where that happens. X squared plus 6x plus 9 equals 0. Now, if I saw this problem on a quiz or on a test, the reality is I would factor this one because it factors very easily. But let's do it by the quadratic formula anyway. We would have x equals, how much is negative b? Negative 6. Plus or minus the square root of, how much is b squared? 36. 6 squared is 36. Minus 4 times a is 1. And c is 9. All divided by 2. So that's negative 6. What happens when I do my 36 minus 4 times 1 times 9? I get 0. What's the square root of 0? Yeah, it wasn't a trick question. Square root of 0 is 0. That's correct. So I have 6, negative 6, plus and minus 0. How much is negative 6 plus or minus 0? It's just going to be negative 6, isn't it? It doesn't matter if I add or subtract 0. Divided by 2. So my answer would be negative 3. So there's one of the weird cases where a quadratic equation only gives you one answer. All right, so this thing b squared minus 4ac, this is called the discriminant. And it tells you a lot about the answers. If b squared minus 4ac is positive, you get 2 real answers. And then we saw that if b squared minus 4ac is negative, you get 2 complex answers. And finally, the last example we just did, if b squared minus 4ac equals 0, you get 1 real answer. That's the strange case with quadratic equations, you almost always get two answers, but it is possible to only get one. Questions about that? All right, my last problem of the day. 4x squared minus 6x minus 12 equals 0. Here's my very favorite thing about the quadratic formula. My very favorite thing about the quadratic formula is once you have a formula, if you know some computer programming, you can program your calculator. So I wrote a program a few years ago for the quadratic formula. So all I have to do is I type in 4, I type in -6, and I type in -12. And my calculator tells me the answer is 6 plus or minus the square root of 228 all over 8, which is approximately 2.637 and -1.137. That's what I like best about the quadratic formula. Because I don't have to write it out and do it anymore. I did it once on my calculator, and my calculator does it all for me. Questions on anything? Will mine work with the 8x squared minus 3x plus 5? Sort of. Yeah. Mine, unfortunately, I need to fix this. This word done shows up here. Because what it really should say is 3 plus or minus square root of 151, and then there should be an I right there. But unfortunately, the word done writes over it. So mine does give complex numbers. Most of the programs that I've seen don't give complex numbers. But mine will. Other questions?
How do you program that into your calculator? Did you just say that?
Uh-huh.
How did you?
So you gotta know about computer programming. So clear home, that clears the screen. Input A, input B, input C. If A equals 0, then don't do anything because A can't be the number 0, right? And then I went and figured out B squared minus 4AC. How come I figured out B squared minus 4AC? What does B squared minus 4AC tell me? It's a discriminant. It told me if I was going to have real answers, complex answers, or only one answer. So then I have some rules. If D equals 0, do some stuff. Figure out the answer and write the answer. If D is bigger than 0, then figure out some stuff and eventually write the answers. So on and so forth. If D is negative, do some stuff and write the answers. So, see, it goes on and on and on. This is what math teachers do when they're giving finals and they have to sit there for 3 hours and they have nothing else to do. They write programs on their calculator. That's literally when I did this. I started it one year during a final, and at first the only thing it would do is give answers for real numbers. And it would only give, oops, that was a bad one. When I first did it, it only gave the decimal approximations. It didn't give me the exact answers until then. A year or so later, when I was giving another final, I rewrote it to give me the real answers and the approximate answers. And then I rewrote it again to give me the complex answers. I had a lot of time to kill while I'm giving finals. Kind of bored.